equilateral triangles is going to be 8 times the sine of 60 degrees is 6.92820 meters. So sum of forces horizontally. I'm going to have Jx and a component of the 5 kilonewtons. So 5 cosine 30 plus Jx, sum of forces equals 0. Summing forces vertically, I'm going to get dy plus jy minus 5 sine of 30 minus 3, sum of forces equals 0. I'll take the sum of moments around J. That will get rid of the Jx and the Jy from my moment equation. Summing moments about J, I'm going to have 28 times dy. This is 8, 8, and 8 is 24. And then I've got another 4 there. So 28 times dy minus 16 times 3. So 8 plus 8 times 3 for the moment arm. For the 5 kilonewton, I'll divide that into horizontal and vertical components and calculate the moments of the components separately. So I've got minus 5 cosine of 30 degrees. The moment arm for that component of force is the h, the height of those equilateral triangles. And then I'll have minus 5 times the sine of 30 degrees times 36. So I've got 8 plus 8 plus 8 plus 8 is 32, plus this another 4 gives me 36. And h is 6.9 meters, so I can solve for dy. dy comes out to be positive 6 kilonewtons. Solve for Jx, which is going to be negative 4.33013 kilonewtons. So I guessed the wrong direction on Jx. Put the value of dy into the second equation, solve for jy. Jy comes out to be negative 0.500 kilonewtons. So I guessed wrong on both Jx and Jy. Next, as I said, I'm going to divide the truss. I want to cut through exactly 3 members. And if I cut a section through here, again, I'll keep the side that has the fewest forces, the one that's going to be simplest to work with. That at least cuts through 2 of the members that I'm interested in, even if it doesn't cut through the 3rd. So I'm going to have the support reaction, 6 kilonewtons. I have the 5 kilonewton load. I'm going to have a tension in CD, a tension in CG, a tension in GH. And again, I apply equilibrium, sum of forces horizontally, 5 cosine 30 minus TCD minus TGH minus TCG. These are all equilateral triangles, so that's still 60 degrees. Cosine 60, sum of forces equals 0. Summing forces vertically, I've got 6 plus TCG times the sine of 60 minus 5 times the sine of 30 equals 0. For moments, some moments about a point that gets rid of as many unknowns as possible. So G is a good point. C would also be a good point. I stuck with G. Summing moments about G, I'm going to have TCG times H sorry, that's not CG, that's CD. TCD times H, I'm going to have the 6 kilonewton times 4. And then again, dividing this into components, I've got minus 5 cosine of 30 times H. And I've got minus 5 sine of 30 times 8 plus 4 is 12. Sum of moments equals 0. So I can solve the last equation immediately for TCD, get plus 5.19615 kilonewtons. Once I know TCD, well, I can solve the second equation immediately for TCG. So TCG is going to be equal to minus 4.04145 kilonewtons. And once I have those two, I can solve the first equation for TGH, and that comes out to be positive 1.15470 kilonewtons. So the two that I was interested in were the CD and the CG. Next, I'll draw a free body diagram of joint C, which is going to be acted on by those 4 forces. I already know that one, I already know that one. Some forces horizontally, some forces vertically. I can find the values of those other 2 forces. And there comes out as listed up there.